Alright, now we got to get to the part where we start converting from an expression in polar form to an expression in rectangular form. And so here's a little summary of those equations. So if you remember that right triangle we wrote in that last section, it's the equations that relate all the x and y coordinates to r and theta. If you make a right triangle with x, y, and r, and then a theta in the corner, then you can have all these equations. And if I write them in vertically like this, you also see them over here to the left, here, the big group of them right there. But if you write them vertically like that, the stuff on the left is all your polar expressions, and the stuff on the right is all your rectangular expressions. They plot the same stuff, they're just different ways of representing it. So when you're doing the conversion process, you look at what you have as an expression. Here's a polar expression that's indicative of the r or theta as your input and output variables. And what we want to do is convert what you have to look like one of the equations you see over in the blue on the left. So we want to get a like I have r equals 2. That's not on my list. Man, if I could just make that r squared, then I'd be good to go. I'd have a replacement for that r squared that uses x's and y's. And so if I square both sides, you get r squared equals 4. And then we replace that r squared with x squared plus y squared equals 4. It is now converted to rectangular form because there's no more r's or thetas, and we have x's and y's instead. If you go to Desmos and graph r equals 2 or graph x squared plus y squared equals 4, they plot the exact same circle with radius 2, which is that's actually the equation. X squared plus y squared equals 4 is in the form of a circle with a center of 0 and a radius of 2. Okay, so now we have the next one is a secant, r equals 4 secant. One of the techniques we use for converting is make it into sine and cosine, because our list of equations has r cosine, r sine. I don't have any secant in there, so we want to change it. And hey, 4 over cosine, if I multiply both sides by cosine, now I've got r cosine is 4. Now that's something I've got a replacement for. You take out the r cosine and put an x in its place. If you graph r equals 4 secant and x equals 4, they graph the exact same thing in Desmos. Okay? So they both, just want to point out that they have these exact same graph. They look the same, just different representations. Next one, if your equation is r equals sine of theta, you multiply both sides by r. So that's another technique. The idea is we're doing some kind of algebraic manipulation so that it is one of the equations on the left, one of the polar expressions on the left that we have a very quick replacement for in rectangular form. So if I multiply both sides by r in number 3, I get r squared equals r sine of theta, and both of those are replaceable with x squared plus y squared and y respectively. That is technically converted. What we'll do is later on we'll complete the square to write it in another form that's more conducive to what we call conic sections and kind of a recognizable form. But for right now, you're converted if you remove all r's and thetas, replace them all with x's and y's. So 4, this one's kind of all set up. Hey, if you have a double angle formula, just like in the past, it's usually the best practice to remove that double angle formula and replace it with an equivalent. So 2 sine of theta, cosine of theta. And then this one's maybe you can see it or not, but if we want to have r cosine, r sine, and tangent and r squared, you could take that r squared that we have. Now you're welcome to call it x squared plus y squared, but I think you're going to make yourself work harder. Another option is to distribute that r, make it go to the sine and the cosine, and then you have 2yx is 8. So that's a converted function. Often we solve for y if we have the option, so we can have a better look at it in a more familiar form. Next is the other way. What if I have x equals x's and y's? Well, actually the start is easier. We just take out the x, put our cosine, and y is our sine. And then usually what we have to do is solve for r, not always. So in this one's just r cosine is -7, that's done, that's converted. There's no more x's and y's, they're replaced. And then solving for r is the icing on the cake. And then the next one, often you want to decide, should I FOIL now or later in these expressions, but you should do it earlier. It's a little bit easier to deal with the x expression. And once you do that, then you can look for things you know you can replace, like x squared and y squared is r squared. The -6x plus 9 equals 9. There's some algebra there. You can cancel the 9s. X is replaceable with a r cosine of theta. And essentially that's done, except for, because once you've removed all x's and y's, you're done. but you can always do a little bit more. Like this case, divide both sides by r and get r equals 6 cosine of theta, and that's a Kirkel, diameter 6, facing to the right. In the last one, same thing. If you know this form, we'll learn later in the conic sections that this is actually a circle of center 3, 2 with a radius of square root of 13, because this is the circle form we use in conic sections, where h and k is the center and r is the radius. So this one happens to be center 3, 2, radius 13 circle. But when we go to polar form, we'll FOIL it all out. Hey, x squared and y squared again are r squared. Like terms, 9 and 4 are 13, and that's actually, there's a 13 on the left and a 13 on the right. They'll cancel with each other. And then there's some like terms, like negative 6x and negative 4x make negative 10x. So this one simplifies pretty nicely, very much like the last one. And if you want to slow this down and follow it later, the idea is you're just combining terms, finding like r squared, x squared plus y squared is r squared, replace x with r cosine of theta, and then if you can get r by itself, awesome. If not, as long as x's and y's are removed, you have converted it successfully to a polar form. I'll cancel the r's again and get r equals 10 cosine of theta, and there's that circle again. It's a Kirkel facing right with a diameter 10. Its center, however, 3, 2 is a little something we can kind of digest a little bit later. But that's the story. Anything more complicated, if you think of it, you're just replacing something with another form. And if you go back to that, had that column of expressions in polar form, column in rectangular form, we're just swapping out the stuff in an equation of one form for its equivalent on the right. And if it's not equivalent, we did some algebra to manipulate it so that we could do a nice, easy swap. That's the story. Hope all is well. Have a great weekend. I'll see you guys on Monday.